Picture this. The year is 1543. The world as we know it is about to change. This is the dawn of a new era. It all started in the heart of Europe amidst the grandeur of the Renaissance, a period of unprecedented cultural and intellectual growth. A time when art was blooming, literature was flourishing, and the human spirit was awakening. But the Renaissance was more than just a cultural movement. It was the seedbed for a profound transformation that was about to sweep across the world, the scientific revolution. The Renaissance, with its emphasis on humanism and individualism, sparked a newfound curiosity in mankind. People started to question, to probe, to explore. The world was no longer a mystery governed by the divine. It became a puzzle waiting to be solved, a book waiting to be read. The established norms were challenged, the status quo was disrupted, and the stage was set for scientific inquiry. In the midst of this intellectual turmoil emerged a man who would forever change the way we perceive the universe: Nicholas Copernicus. Born in the Kingdom of Poland, Copernicus was a mathematician, astronomer, and a cleric. He was a man of the Renaissance, a man of curiosity, a man of courage. Copernicus dared to question the geocentric model of the universe that had been accepted for over 1,000 years. He proposed a radical theory, a heliocentric model, where the sun was at the center and the earth revolved around it. This was a revolutionary idea. It challenged the very foundations of the universe as understood by humanity. It was a theory that was audacious, controversial, yet undeniably intriguing. And thus, the stage was set for a revolution that would redefine our understanding of the world. This was the dawn of a new era, an era of science, an era of discovery, an era of truth. The scientific revolution was about to begin and nothing would ever be the same again. Enter Galileo Galilei, a man whose name became synonymous with the scientific revolution. Born in the late 16th century, Galileo was a physicist, mathematician, and astronomer who dared to challenge the commonly accepted views of his time. His contributions to science were numerous and profound, but let's focus on a few that particularly stand out. First off, let's talk about Galileo's use of the telescope. While he didn't invent the telescope, he was the first to use it for astronomical observations. With this device he observed the moon, discovering its mountains and craters, and brought into question the Aristotelian belief that the heavens were perfect and unchanging. He also spotted 4 moons orbiting Jupiter, providing the first evidence of bodies in motion around a center other than Earth. Then there's Galileo's support of Copernicanism, the theory that the Earth and other planets revolve around the sun. At a time when the geocentric model, placing Earth at the center of the universe, was widely accepted, this was a radical and controversial stance. His publication, Dialogue Concerning the Two Chief World Systems, presented arguments for both the geocentric and heliocentric models, but clearly favored the latter. These groundbreaking claims, however, were not without consequence. Galileo's support of Copernicanism brought him into conflict with the Roman Catholic Church, culminating in a trial in 1633. Accused of heresy, he was forced to recant his beliefs and spent the rest of his life under house arrest. This trial illustrated the tension between science and religion, a theme that would reoccur throughout history. Despite the adversity he faced, Galileo's work formed the foundation of modern physics and astronomy. His unwavering commitment to scientific truth, even in the face of persecution, set a precedent for future scientists. Galileo's courage to stand up for his beliefs paved the way for future scientists. Now imagine a world where gravity doesn't exist. Apples wouldn't fall from trees, we wouldn't walk but float, and Earth would not orbit the sun. Sounds like a science fiction movie, doesn't it? But this was the reality until a certain Englishman stepped into the scene. Enter Sir Isaac Newton. Born in a small hamlet in England, Newton would grow up to become one of the most influential figures in the scientific revolution. His work paved the way for modern physics, and his laws of motion form the bedrock of the subject. The first law, also known as the law of inertia, states that an object at rest stays at rest and an object in motion stays in motion with the same speed and in the same direction unless acted upon by an unbalanced force. It's the reason you lurch forward when a car suddenly stops. The second law of motion is about force. It tells us that the force acting on an object is equal to the mass of that object multiplied by its acceleration. This is why it's easier to push an empty shopping cart than a full one. The third law, the one we've all heard in some form or another, states that for every action, there's an equal and opposite reaction. It's the reason rockets can propel upward, despite there being no solid ground in space to push off of. But Newton didn't stop at the laws of motion. He went on to discover gravity, the unseen force that keeps us grounded on Earth and the planets in their orbits. Newton's law of universal gravitation was revolutionary, providing a unified explanation for what was happening both on Earth and in the heavens. This was a monumental leap in our understanding of the universe. It was a shift from a world where phenomena were explained through the whims of the gods to a universe that followed clear, definable laws. Newton's laws not only explained the world around us but also the cosmos above. The scientific revolution didn't just change science, it changed society. It brought about an era known as the Enlightenment, a period that deeply impacted philosophy, politics, and society at large, as the world began to revolve around reason and rational thought. Let's delve deeper into the cradle of the Enlightenment, a time when the seeds of the scientific revolution began to bloom in the minds of the people. As scientific thought began to infiltrate society, it started to challenge the existing norms, beliefs, and institutions, leading to a radical shift in how people perceived the world around them. Enter key figures like Voltaire and Rousseau, who were at the forefront of this intellectual revolution. Voltaire, a fierce advocate for freedom of speech and religious tolerance, was deeply influenced by the scientific approach of questioning and testing. His writings were a testament to the power of critical thinking, and his advocacy for empirical evidence was a clear echo of the scientific revolution. Rousseau, on the other hand, brought the scientific method into the realm of politics and society. He questioned the divine right of kings and proposed a social contract where the power of governance lies with the people, a radical idea that was grounded in the principles of rationality and evidence-based reasoning. As the Enlightenment spread its wings, it brought about an age of reason and progress. The idea of human rights, the separation of powers, and the principles of democracy that we uphold today all have their roots in this period. The Enlightenment was not just a period of intellectual growth, but it was also a time of social and political evolution, a time when humanity began to explore the power of reason and rationality. In essence, the scientific revolution was not confined to the laboratories and observatories. It spilled over into the streets, into the minds of the people, and into the very fabric of society, igniting a spark of reason and rational thought. The scientific revolution sparked a light in the minds of people, leading to an age of reason and progress. So where does that leave us today? The scientific revolution, a period that spanned the 15th to the 17th centuries, was a turning point in human history. But the echoes of this era are not confined to the dusty pages of history books. On the contrary, they reverberate through our modern world, shaping not only how we understand the universe, but also how we perceive our place within it. The scientific revolution brought about a shift in thinking, one that moved away from a reliance on superstition and dogma, and towards observation, experimentation, and reason. This new approach to knowledge, known as the scientific method, is perhaps the most enduring legacy of the scientific revolution. Even today, it remains the cornerstone of scientific inquiry, guiding researchers as they seek to unravel the mysteries of the universe. Moreover, the revolution's impact extends beyond the realm of science. Its emphasis on evidence and rationality has permeated our societies, influencing everything from our political systems to our educational institutions. It has fostered a culture of critical thinking, encouraging us to question, to investigate, and to seek out truth, rather than accept things at face value. But perhaps the most profound impact of the scientific revolution is the way it has shaped our worldview. It has taught us that the universe is not a chaotic, unpredictable place, but a cosmos governed by laws that can be understood through careful observation and reasoned thought. This belief in a rational, knowable universe is a cornerstone of our modern world, underpinning everything from our technological advancements to our quest for knowledge about the cosmos. And so the legacy of the scientific revolution lives on, not just in the laboratory or the classroom, but in the very fabric of our societies. It is a testament to the power of human curiosity and the relentless pursuit of knowledge, a story of how a revolution in thinking can change the world. The scientific revolution wasn't just a period in history, it was the beginning of a journey that we're still on. But what's next? The journey that began with the scientific revolution is far from over. We continue to push the boundaries of our knowledge, exploring the furthest reaches of space, delving into the mysteries of the quantum realm, and seeking to understand the very fabric of reality itself. The spirit of curiosity and discovery that ignited the scientific revolution still burns brightly today. It fuels our quest to answer the big questions. What is the nature of the universe? How did it begin? What is our place within it? And perhaps most importantly, what does the future hold? As we stand on the shoulders of the giants of the scientific revolution, we continue their work using the tools and methods they developed to explore the unknown. But we also face new challenges and questions that they could never have imagined. In the face of these challenges, we must remember the lessons of the scientific revolution. We must remain open to new ideas, willing to question our assumptions, and ready to change our minds in the face of new evidence. Only then can we hope to continue the journey they began and push the boundaries of what is possible. So as we look to the future, we must remember the legacy of the scientific revolution. It is not just a story about the past, but a roadmap for the future. A reminder of what we can achieve when we dare to ask questions and seek out answers. The scientific revolution wasn't just a period in history. It was the beginning of a journey that we're still on. And if you enjoyed this journey, don't forget to like, comment, and subscribe for more such enlightening videos.